Alrighty. So our first example states y equals 5 times x squared plus 3x minus 7 raised to the negative fourth power. So informally, when you look at the chain rule, right? If you have a composite function, let's say y equals f of g of x, and you rewrite this as f of u, where u replaces the g of x, then by the rules for chain rule, we say that dy over dx, or simply y prime, is going to equal to f prime of u times u prime, which essentially means that you take the derivative of the outer function and you multiply it by the derivative of your inner function. So I'll show you how I use this particular rule for the example that we have. If you have 5 times x squared plus 3x minus 7, the first thing that you want to identify is your inner function, your u. What do you think u is going to be? Yeah? That's right. Your u is going to be the x squared plus 3x minus 7. So we say let u be equal to x squared plus 3x minus 7. Then you can take your derivative. You can say that du is, sorry, not du, my bad. Oopsie. Sorry, we have u is equal to x squared plus 3x minus 7. I got carried away there. I was thinking about calculus 2 for a moment. So the next thing that you want to do is just rewrite the function in terms of u. So if u is replacing x squared plus 3x minus 7, then what we're going to have is f of u will be 5 times u to the negative fourth power. All right, now we can go ahead and take our derivatives. If u is equal to x squared plus 3x minus 7, then u prime should be 2x plus 3, right? Derivative of x squared is 2x. Derivative of 3x is now plus 3, and the derivative of negative 7 is 0. That goes away. Now, f of u is equal to 5u to the negative fourth power. So this implies that if we take the derivative with respect to u, you're going to get 5 times negative 4, which is negative 20, u raised to the power of negative 4 minus 1. Now, what is negative 4 minus 1? Negative 5. All right, so you put this together. What we're going to have is y prime equals to negative 20 u to the negative fifth power times u prime, which is 2x plus 3. All right, we're almost finished. When you're finding your derivative, especially with respect to, in regards to x, you have to make sure that your derivative is written in terms of x. So you rewrite the u based off of what it was originally defined as. And because the power was negative, you could bring it into the numerator, bring it down into the denominator with a positive exponent. So this will be negative 20 over x squared plus 3x minus 7 raised to the fifth power times 2x plus 3. Now, if you want to write this as a single fraction, you could just take negative 20, multiply it by 2x plus 3. That will give you negative 40x minus 60, all divided by x squared plus 3x minus 7 raised to the fifth power. That would be your derivative. Okay. So that is my first example. Let me just come back to example 2. Let me just jump straight to example 5. Okay, you'll see why in a moment. So in example number 5, you have y equals the square root of 7 plus 2 cosine of x. This is a problem that involves a chain rule, okay? But you have to rewrite this equation. In particular, you need to rewrite it where you're rewriting the radical using a fractional exponent. So since this equation reads the square root of 7 plus 2 cosine of x, then the the square root part can be written as what as what? Say again? 1/2. There you go. All right. So now you can label your inner function. You should be able to clearly see what your inner function is. So what would you like to let u be? That's right. Let u equals to 7 plus 2 cosine of x. Now you can go ahead and you rewrite your equation in terms of u. So this will give you f of u is now u to the power of 1/2. Now you find your derivatives. Find u prime, find f prime of u. So if I want to find the derivative of 7 plus 2 cosine of x, first of all, derivative of 7 is 0. That goes away. Now, anybody remember what's the derivative of cosine? Negative sign, right? Remember, cosine starts with the letter C. This COS looks like I'm saying CUS, right? Like cuss, and we know cuss is a bad thing to say, right? So what sign goes with bad words? A negative sign, right? So therefore, the derivative of cosine is negative. That's just one way of remembering it. So since the derivative of cosine is negative sign and we have the 2 in front of it, we're going to get negative 2 sine of x. Okay, good. Now you could apply your power rule for derivatives to get f prime of u. Bring the 1/2 down. You have 1/2 of u, and then you subtract 1 from your exponent. If you subtract 1 from the exponent, what's 1/2 minus 1? Negative 1/2. All right, so what we're going to say is, so y prime is equal to the product of f prime of u times u prime. That is precisely 1 divided by 2u to the power of 1/2. So please note that because this power was negative, I could rewrite u to the negative 1/2 using positive exponents by bringing it down to the denominator, multiplied by negative 2 sine of x. Now, remember, when you find your derivative has to be written in terms of the variable x. So 1 times negative 2 sine of x, that will be on the top, or just negative 2 sine x. And the denominator, where we have the u, you replace it based on what you defined it as. Here we defined it as 7 plus 2 cosine of x. So it's 7 plus 2 cosine of x raised to the power of 1/2. Any questions so far? Say it again. Oh, yes, you can rewrite it back as square root of 7 plus 2 cosine of x. But you can leave the fractional exponent for now. That's fine. MyLab, if you're doing like this, for example, on the MyLab homework, or you're doing this on the exam, you could leave it raised to the 1/2, or you could write it using a radical, like the square root. Okay. Questions so far? Yes, Tyler, you could definitely, I just realized that. Yes, you can definitely divide the negative 2 over 2 to reduce it if you like. So yes, I know MyLab would penalize you for this. So yes, you can definitely rewrite this. You can say that it is negative sine over x, all divided by 7 plus 2 cosine of x raised to the power of 1/2. That is correct. You could simplify it just a tad bit. Any other questions? All right. So the reason why, by the way, that this idea of a u sub works is because it comes from the general power rule, essentially, right? This is what we call the general power rule. But now, the general power rule helps because when you write f of u, u is your monomial, it's a single term where you can use basic derivative skills or basic derivative rules to find that derivative. Now, when you have functions that are no longer resembling a monomial, a single term, more like a trig function or a ln or e, there are specific chain rules that you apply. And I'm going to start with problem number 2 to show you. Right, so just make a note. Right, these are just extensions of the chain rule. It states that, if you want to find the derivative with respect to x of ln of u, where u is a function of x, then this is now going to be u prime divided by u. In addition, if I say find the derivative with respect to x of e to the u, this will be u prime times e to the u. Okay, so these are a couple of couple of extensions to our chain rule. Okay, so I'll show you how it works in problem number 2. Problem number 2 says you have ln of 3 plus e to the x. So you can make a u substitution here. If you apply a u sub here, then the u is going to be your 3 plus e to the x. All right. So if we say u is equal to 3 plus e to the x, what is our derivative? What is our u prime? Not 2x. Not 2dx. Remember, it says u equals 3 plus e to the x. So first of all, what is the derivative of 3? 0. What is now the derivative of e to the x? It's going to be itself. Very good. So u prime is going to be e to the x. So y prime is equal to e to the x all divided by 3 plus e to the x. That's it. E to the x is my, right? This piece is my u prime. This is my u. ln of u is u prime over u. Okay, let's look at number 3 where it gets a little bit more interesting now. Now, number 3 says y equals ln of 3 plus e to the power of x squared. So what do you think will be my u? That's right. Your u is going to be 3 plus e to the power of x squared. Now we have to take our derivative. What is the derivative of 3 again? 0. That's going to go away. Now be careful here, because this does not say, the next term does not say e to the x. It says e to the power of x squared. So since we no longer have just an x as an exponent, the derivative is not going to be e to the x. To get the derivative of e to the x squared, you apply your chain rule. And one thing about chain rules is that you can apply a chain rule within a chain rule. You can apply a chain rule within a chain rule. So my du here is going to be, I'll use this notation. If I apply my chain rule to the right, I will say, I'll just use a different letter. We'll have e to the v times v prime. So I'm letting basically this x squared be my v. Okay, if v is equal to this x squared, then what would be its derivative? 2x. Very good. So now we just replace it for our du, right? So what we're going to have is e to the power of x squared times 2x. Now we put all of this together. Oh, by the way, I'm so sorry. du is one of the notations that we use in Calc 2, but instead I'm just going to call it u prime since you guys are beginning with derivatives here. Okay, so what we're going to have as our final answer is that y prime is now 2x times e to the power of x squared over 3 plus e to the power of x squared. And that will be our solution. C of 2, if you don't mind. Yes, I can. I just got one more example to do. I know what example you're referring to, but just give me 1 minute. All right. Let's look at one more example of a chain rule, and then I'm going to stop the recording and look at your example, take any other questions. So my fourth example states that we have y equals 5 plus 9x raised to the 50th power times e to the power of 6x. Now, first of all, this is a problem that involves a chain rule. But what else does this problem involve? What derivative rule? Yeah, a product rule. All right, so I'm just going to write a recall moment. Recall that if you want to find the derivative with respect to x of f times g, we say that this is f times g prime plus g times f prime. Okay, so I'm just going to do a little scrap work, and then I'm just going to see, you're going to see that I'm cross multiplying. So f will be the first function, 5 plus 9x, where all of it is raised to the 50th power, and g is e to the power of 6x. Now, you have to find your derivatives, f prime and g prime. If you want to find your derivatives here, you need to use a chain rule. So if I apply my chain rule, these examples of the chain rule is relatively simple, I think. With enough practice, you should be able to find them. But I'm just going to let you know what they are. For the first one, f, your inner function would have been 5 plus 9x. So you would have taken the derivative of the outer function. So you would have bring the 50 down. You could keep the 5 plus 9x raised to the power of 49 times the derivative of the inner function. Now, what is the derivative of 5 plus 9x? 9. Very good. You can simplify this just a tad bit or expand it out. You could do 50 times 9 to say you have 450 times 5 plus 9x raised to the 49th power. And now, if you have g is equal to e to the power of 6x, this is going to be equal to the same function times the derivative of your exponent. So what is the derivative of 6x? 6. So we write the 6 e to the power of 6x. Now, informally, it looks like we're going to do like a cross multiplication. You do f times g prime, and then you're going to do g times the f prime. This will give us that y prime is equal to f times g prime. So it's, I'll put the 6e to the 6x first, times 5 plus 9x raised to the 50th power, plus e to the power of 6x. Sorry, I can write is e to the power of 6x multiplied by f prime. But since there's a constant multiple of 450, I can write the 450 first. So it's 450 e to the power of 6x times 5 plus 9x raised to the 49th power. And that will be my final answer. You can simplify this a little bit. I wouldn't recommend expanding. You could have simplified by factoring a little. But this is a totally fine answer because all this question was requiring you to do was to apply a product rule that incorporates a couple of chain rules.